Hello everyone, welcome to our DIY group project by Team-19. I'm Khushi Agrawal and I would be introducing the topic of our group project. So basically, our project is based on automatic rain sensing car wiper with headlamp control. Moving on, the contents are scope and objective, principle, positioning of the sensors, required hardware and software, code, circuit diagram, project timeline, division of work, and the final output. So from here onwards, Aryan Garg would carry on with the further explanation.
Scope and objective. As per some international surveys around the world, most of accidents occur at night time or adverse weather conditions. These accidents are mainly because of driver inattentiveness while driving. Thus, an autonomous car will ensure a safe and easy driving without much human intervention. The effect at nighttime due to high intensity beam 2 is responsible for fatal accidents. The project aims at developing a device or system to sense the intensity of headlight from opposing vehicle and switching the intensity of headlight automatically based on readings from sensor. Furthermore, automatic rain sensor will help the driver in getting a more clear vision during rainfall by increasing or decreasing the speed of the wipers accordingly, thus avoiding any difficulty in driving. Now, let me explain the principle. The rain sensor works on the principle of using water for completing its circuit. The sensor mainly consists of two parts, sensing pad and sensor module. When rainfall falls on sensing pad surface, the switch will be closed. The sensor module reads data from the sensing pad. The microcontroller now processes the data, converts it to a digital or analog output, and drives the motor IC to perform the required action. The motor driver IC now drives the servo motors to stimulate the car wipers. Here are the specifications of rain sensor module. The first figure shows the sensing pad hardware overview. The second figure shows sensor module hardware overview. The third figure shows the specifications of the pins of the sensor module. And the fourth figure shows the rain sensor specifications. Now Saksham will continue with the principle and further explanation.
This work prototype of headlight system is made by using Arduino photoresistor, LEDs and other accessories. The photoresistor is the type of resistor where the resistance varies with light intensity. The relationship between the resistance and light intensity is negatively proportional, meaning that as the light intensity increases, the resistance decreases. About the positioning of the rain sensors, the rain sensor module is placed at the top middle of the windshield and the LDR is placed between the two headlamps. Required hardware and software. Software required were Tinkercad and Arduino IDE. Hardware components required were Arduino Uno R3, servo motor, rain sensor module, breadboard, jumper wires, cardboard, photoresistors, LEDs, one resistor of 3.7 kilo ohm and four resistors of 100 ohm. Since we assembled our project in DIY lab, it cost us only 250 rupees. Now I would like my friend Manaswi to continue the code for the project.
So let's start. So first, we have included a servo.h library using the pragma hash include, and then we have defined two variables which are available in the library called myservo and myservo1, and then we have initialized and declared and initialized some values, and here we have LED1 and LED2 for the dipper, and LED and LED3 for upper headlamp, as you can see in the comments. Then in the setup function, we have used that serial.begin to 9600, and then we have printed out the sensor value on the screen. Then we have the loop part where we have initialized the sensor value to the reading at A0 pin, and then we have again printed the sensor value on the screen. Now we have the logical part where we have, if the sensor value is greater than 600 and less than equal to 800, that is in between 600 to 800, we will start a loop. First loop starting from position equal to 0 to position equals to 120. This loop will correspond to the motion of the wiper from its initial position to the final position for one oscillation. And then we have the we will start another loop from position 120 to position 0, where which will be responsible for the return of the wiper from the final position to the initial position, and in both these loops the delay will be for 3 milliseconds. Then when these loops will end, there will be a delay for 2 seconds between the motions of the wiper. One full motion, and then there will be a 2 seconds break, then another full motion, then there will be a 2 seconds break. And if the sensor value is greater than 560 and less than equal to 600, that means in between 560 to 600, we will again start a similar kind of loop where the first loop will be responsible for the motion from initial to the final position, and second loop will take the wiper from final position to the initial position. In both these loops, the delay is for 3 milliseconds, and after this loop is finished, we have a delay for 1 second. And similarly, if the sensor value is less than 560, a similar kind of thing occurs. The only difference being the delay is for only 0.1 seconds. Now for the headlamp part, if the sensor value is less than equal to 150, the LED and LED3, they will be dim, and LED1 and LED2 will glow high. Um, and then we have LED, and if the sensor value is greater than 150, then all the LEDs will glow brightly. In the above part, as you can see, um, LED1 and LED2 were for the dipper part, so they will glow, and LED and LED3 were for the headlamp, so it will be dim.
So this is the schematic of our group project, which comprises of the automatic rain sensing wiper and headlamp control. So I'll take you through a brief overview of all the components used and their connections. So this is our Arduino Uno R3 connected to the breadboard. These are 4 LEDs which would be depicting the working of our headlamps. The upper 2 LEDs actually represent the upper lights of our vehicle, and the lower 2 LEDs represent the dipper lights of our vehicle. These are resistors of 100 ohm each connected to the LEDs, and this is a multimeter. These are the 2 servo motors which would be representing the working of our rain sensing wiper. This is a photoresistor for the detection of light intensity, and this is a multimeter again. And this is the whole rain sensor module comprising of the sensing pad and the sensor module. Now talking about the connections, the sensor module is connected to analog pin A0 to the Arduino, then photoresistor is connected to analog pin A1. One of the servo motors is connected to digital pin 9 and another one is connected to digital pin 10, and the other 2 connections are of the ground wire and of the 5-volt supply. Then talking about the LEDs, the upper lights are connected to digital pins 7 and 2, and the dipper lights are connected to digital pins 6 and 3. So this is the Tinkercad software, and we'll start this simulation to look at the working of our headlamps. So until the vehicle is encountered by an opposite vehicle, it can travel with high beam, that is both upper and dipper will be on. So this is this condition when there is no approaching vehicle and both our upper and dipper are on. Next, if either of the vehicles are using high beam, then it switches to low beam, that is the upper lights go off and the lower or the dipper lights, they remain on, so that the glare in our eyes is not excessive enough to almost blind us or to cause any accident. So for this safety purpose, this upper and dipper light system was made. So this was done with the working of our headlamp. The demonstration of the servo motors cannot be shown here because there is no component of a rain sensor module present in Tinkercad. So it would be depicted in our demonstration of the hardware assembly, plus it would be explained in the code.
Project timeline. This is the way in which we progressed with our project.
So now these are our 4 team members, and given below is the work that we divided among ourselves.